Really excited to be here with all of you. So thank you for taking time out of your busy days to join us today at the GroupBy conference. This is my first time speaking as part of GroupBy, so I'm really excited to talk about Azure SQL, what to use when. And as Alexander said, I work at Microsoft. I do a lot of this sort of thing, but I also do some data science work around retention. So looking at some of our telemetry and trying to figure out how we can get more customers to stay. So that's kind of me. And today, what I really want to do is talk about Azure SQL. So I want to give a holistic, hopefully, introduction to what Azure SQL is, what the different options are, and how you might go about choosing these options. Now, throughout the session, I also have some quizzes to see if you're paying attention. Unfortunately, I don't have any prizes, but it's just bragging rights potentially if you get a question right. And then we also are going to talk about, also see some demos. So you'll have the opportunity to take some quizzes, see some demos, and we'll take questions kind of throughout those opportunities. But what I really like to start with when we talk about what to use when we talk about Azure SQL is the history of Azure SQL. Now, I'm going to make a big assumption that most of you viewing this session have heard of SQL Server, right? And SQL Server has been around for longer than I've been alive. I think I won't age myself, but longer than I've been alive. And so it's a very well-known product. But when we talk about Azure SQL, this is something that I wanted to go back in time to 2008. This was Microsoft's chief software architect at the time at our big developer conference. He got on stage and announced Windows Azure, our Microsoft cloud, for the first time. And I really like this because what you see is right front and center is what was then they were calling SQL services. So this is really cool. And I think, what to use when also applies here because he said, really, if you want someone to manage your availability, your disaster recovery, your backups, your updates, then that's a good opportunity to use SQL services. And I think that message of what to use when still largely applies, even though since then we've come such a long way. So apart from all of the name changes, which you can see we've done for our product. So actually at the beginning, we were SQL Azure, and now we're Azure SQL. So I'm not sure what's next, but I'm sure there are some name changes to come. But just interesting to see how we've kind of expanded our different offerings related to Azure SQL Database, Azure SQL Managed Instance, Hyperscale, Serverless. So I thought a good place to start before we dive into the different options and when you might use what is to look at what we consider Azure SQL today. So the first thing I want to talk about is SQL Server and an Azure virtual machine. So this is exactly what it sounds like. This is the version of SQL Server you specify on the OS you specify with the version of that OS that you specify. So this is really great if you need access to the OS. Now, we'll dive deeper into each of these, but as we go from left to right, something to remember is that we're going to abstract away things from you, the customer, and in turn take on some more responsibility, but also give you some of those benefits. So the first one is Azure SQL Managed Instance. And this is one of our platform as a service or PaaS type of offerings. And this is great if you say, I don't want to manage the OS. I just want a managed SQL Server. So that's great for Azure SQL Managed Instance. And then on top of that, we have some customers that say, I don't even really need the instance scoped capabilities. I just need a SQL database, and I want to take advantage of some of the latest innovations like Hyperscale, like Serverless. So those are kind of the main options we're going to talk about today, and then we'll dive into some specific options available for the platform as a service side. All right, so the first one we're going to cover is SQL Server on an Azure virtual machine. So this is great because we say it provides the promise of the cloud while maintaining OS control. So let's talk a little bit about the challenges that lead customers to selecting this option. Okay, so perhaps we have customers running SQL Server 2008 R2. Now, believe it or not, even though SQL Server 2008 R2 reached end of support almost 2 years ago, a year and a half ago, there's still a lot of folks, and maybe some of you on this call, that are running SQL Server 2008 in your environment. So we have a lot of customers trying to figure out what to do there. How do we maintain and get more security updates if we're not quite ready to upgrade yet? We also have customers who leverage third-party software. So maybe you have a third-party software solution, but that needs access to the OS. Now, these are two big reasons, and also maybe you want to fail over as quickly as possible. So these are two big reasons we see customers landing in SQL Server in a virtual machine. And what it is really just that. Like I mentioned, you get to pick the exact SQL Server and OS version that you need. You can also get every SQL Server capability that's available, as well as things in the box product like SSAS, SSRS, SSIS. Maybe you're not quite ready to move to something like Power BI. You have a bunch of SSRS paginated reports. Well, we have options for you there. You can actually deploy a SQL Server Azure Virtual Machine with SSRS as well, and kind of have those running side by side. And we have SSAS images, I think, coming soon as well. One of the great things about moving to Azure for this, if you were to say, okay, well, I could just move to a VM anywhere, is that if you're running SQL Server 2008 R2, we're going to actually allow you to get extended security updates for the next few years. So you can some kind of get by with SQL Server 2008 for a few more years if you absolutely need to and are not upgrading yet. We also do some things related to performance to really help you stay fast. And I'll talk a little bit more about those options that you have. And a customer that I really like is Allscripts. And I like this customer because they were able to, in a matter of weeks, just fail over, like over 600 virtual machines. They use a technology called Azure Site Recovery. Just allows you to basically fail over virtual machines into Azure. They were able to fail over about 600 VMs, less than 2 weeks. And what I like is that once they were in SQL Server and Azure Virtual Machine, they got all their environment configured, they started to evaluate the PaaS offerings, and they actually started to move some workloads to Azure SQL Managed Instance. So I think this is a great example of taking a phased approach to migration. Go to SQL Server and Azure VM, get comfortable with the Azure platform, and then move to something like Azure SQL Managed Instance where you get less management overhead that's required. Now, I'm not going to talk a ton about virtual machines for the rest of the session, but there are a few things I wanted to call out. Lots of words on this slide. I'll provide all these resources so you can dive deep into each of these topics as you want. But the main thing I wanted to mention is under that second offering. So SQL Server people, hopefully there are some of you on the call. If you're familiar with how you might install SQL Server, what you would do is you would go, and if we had a virtual machine, maybe you go to the Azure portal, you deploy a virtual machine, and then you'd install SQL Server. This is very common, and we have a lot of customers that do this. Now, the one caveat to that is there is another way. The other way, and I'll show you this in a demo, is you can actually go into the portal and deploy the specific pre-installed image. So basically you go install a SQL Server 2019 running on Windows Server 2019 and even the licensed version, and you can go and just deploy that virtual machine and SQL Server is already installed. Now, the main difference between these two options, a self-installed versus a pre-deployed image, is that the pre-deployed image comes with this SQL IaaS extension, which IaaS stands for Infrastructure as a Service. And this SQL IaaS extension is going to allow you to unlock some platform as a service goodness. So some managed service capabilities on your pre-deployed image. But your self-installed virtual machine doesn't come with this by default. So my one takeaway for Azure SQL Server on Azure Virtual Machine is make sure you go install the SQL IaaS agent if you do go the self-installed route, or maybe you already have gone the self-installed route. Make sure you have the SQL IaaS extension. It's really going to help you take advantage of some of the financial benefits, especially if you already have some sort of SQL Server license, and some other things as well. And there's really awesome things we're working on in this space. One of the coolest things I saw recently was a wizard to deploying an always-on availability group in the portal. And it was just like a few clicks, and now I have an always-on availability group, which was pretty amazing for me because those things are very complicated to set up. I don't know if anyone has tried or attempted that before. All right, so that's SQL Server on Azure Virtual Machine, and that's our IaaS Infrastructure as a Service solution. Now, before we go forward, I wanted to kind of compare and contrast because the rest of the session, we're going to be talking about Platform as a Service. Now, if we look at all the things, these are kind of all the things you look for in a managed service, right? And if we compare IaaS versus PaaS, what happens is with IaaS, the way I think about it is a lot of these things are configurable. Like you can go, like I just mentioned, you can go and figure out how to deploy an always-on availability group with your SQL Server in an Azure virtual machine. Whereas if we contrast it with PaaS, a lot of those things are just built in. For example, if you go deploy a database in the business critical tier, which we'll talk about, we actually underneath the hood deploy an always-on availability group for you. So you just get that. So that's just one example. We actually have an SLA for a platform as a service database. And then the other big thing, there are lots of differences, but the other big thing between IaaS and PaaS is this concept of versionless. Now, those of you familiar with SQL Server are very familiar with, every few years or even when there's a new cumulative update, you have to go update SQL Server. And sometimes this breaks you, you have to test, it can be a big ordeal. And with IaaS, you still have to do that, right? Like we can do some security patches, but we're not upgrading you. Now with PaaS, you enter this new world with Azure SQL Managed Instance and Azure SQL Database where you no longer have to do updates. We are a versionless SQL Server is what we say. So basically we fork the engine, the SQL Server engine, we fork it, and the Azure SQL Database and Azure SQL Managed Instance one, we're able to update more frequently because we push the updates to you, and the responsibility is on us as Microsoft to make sure that we don't break you when we upgrade. So kind of that's like the big benefit. One of the really big benefits I think to platform as a service is never having to go and upgrade or wait for things to hit the box product. Kind of these things come available, and we try for the most part to go cloud first. So they'll land in Azure SQL Database or Azure SQL Managed Instance, oftentimes before landing in the SQL Server box product. And you also don't have to upgrade. So that's kind of the biggest differences between IaaS and PaaS. So now let's dive into the two main options we have for that, starting with Azure SQL Managed Instance. Now, we came up with Azure SQL Managed Instance after Azure SQL Database, and there was a big reason for this. So we had a lot of customers, they want to move to this managed type of service. They heard the benefits of PaaS and they said, sign me up, right? I want an SLA. I want to be able to get an availability group without deploying it. I want, to be able to set up geo-replication or auto failover groups without any challenges. And I also want instance scoped features. That was the big caveat, is like Azure SQL Database just gives me database level capabilities, but I need things like Service Broker, DTC, machine learning services, SQL Server Agent, Database Mail, CLR. Hopefully you all are familiar with those. If not, don't worry about it. Maybe Azure SQL Database is better for your scenario, but there's a lot of customers that needed those things. And so we said, okay, we'll come up with Azure SQL Managed Instance. This was, maybe 5 years back. And we said, we're going to give you the ability to get those instance scope features. So you kind of get a managed SQL Server, but you still get the capabilities from SQL Server box product. So we say this is kind of the best of SQL Server, what you're familiar with on-prem, with the best of a managed service, because you are still going to get some of those platform as a service benefits that I mentioned. Now, one customer I like to talk about is Komatsu. And I think this customer is really interesting because they were able to move their database, a pretty sizable database with no code changes, very quickly and see huge improvements, whether it was cost reduction. So you see their cost reduction of 49%, that's huge, and performance gains of 25 to 30%. So really big step of progress as far as cost and performance with a company like Komatsu. So something to consider as you move to the cloud. Do you need these instance scope features? And if you don't, then a solution like Azure SQL Database might be a good option as well. So this is our original product. So when I showed that Ray Ozzie at the chief software architect announcing SQL services, this was the original, right? Azure SQL Database. This was built for modern cloud apps. So there's a lot of reasons why we see customers moving to this. So a few reasons, one, people don't want to deal with upgrades. They want everything associated with a platform as a service. So they like the idea of Azure SQL Database. Two, potentially they have a multi-tenanted service. So, for example, we have a customer called Paychex, and they have like 600,000 customers running in elastic pools, which is basically the ability to have lots of databases, but they're sharing resources. So this allows you to cost optimize and kind of share across, which can be great cost savings for a software as a service type of provider. Maybe you have like a ton of data, but you don't really want to put it in a data warehouse. It's still largely OLTP type of workloads with some analytics on top of it. Maybe, but it exceeds the 4 to 8 terabytes that typical Azure SQL Database or Azure SQL Managed instance provides. We'll talk about the solution for that, which is Hyperscale. Or maybe, you've been hearing a lot about this idea of serverless and only paying for what you need and what you use. And Azure SQL Database has that capability and we'll talk more about that as well. We also have private link support, so you can have a totally private endpoint. If you do like a DNS lookup, you won't see any of that information that you can sometimes see otherwise. And Azure SQL Database is going to give you the industry highest SLA of 99.995% of uptime, which basically amounts to less than 26 minutes a year of downtime. So that's pretty significant. And, a customer I like to talk about here is AccuWeather, because they really just wanted to start building a new application. They wanted to build a modern application. They wanted to take advantage of the whole Azure platform, not just the database side. So they started working with things like Azure Machine Learning Services, Azure Data Factory, to kind of build this scalable prediction service for their company. So that's a really great example. Now, you might be wondering, okay, you showed me those 3 offerings, SQL Server and Azure Virtual Machine, Managed Instance, and SQL Database. How do I know which offering is really right for me? Now, if we think about it, and this isn't going to be the end all, this is just trying to simplify as much as we can. But really, at the end of the day, the answer is, of course, it depends. But the 3 main pillars we see are migration, app modernization, or app innovation. So depending on what phase you're kind of in might help you lead towards a virtual machine, managed instance, or a single database. It also comes down to 2 things. What type of control do you want, right? So that's customer manage, you manage it, or Microsoft manage it, we manage it. And then what kind of capabilities you need. So if we look at customer manage and full control, full capabilities of SQL Server and the OS, that lands you in SQL Server and an Azure Virtual Machine. Now, if we talk about the managed side of Microsoft Manage, do you need instance scope features? And I talked about some of these instance scope features. Then Azure SQL Managed Instance is going to be the easiest for you to move to. And we talk about easiest to move to. You could move to any of these, but it might require some app modernization or some re-architecting, depending on what option you choose and what your current environment requires. Now, if you don't need any of these capabilities potentially, then you can move to something like Azure SQL Database, where we manage a lot of this for you, and you have those options like Hyperscale and Serverless. So now what we're going to do is we're going to try a quiz. So I'm hoping you can all access the chat. Maybe Alexander, can everyone access the chat? Is that possible?
They should be able to do that.
Awesome. Cool. So if you can access the chat, we would love for you to participate. What we're going to do is I'll read these scenarios, and whenever you have the answer to both questions, just put the answer to both questions in the chat. So for example, if you think the answer to both questions is D, just put D in the chat. So feel free to put your answer in whenever. This is just a brief quiz. There's nothing like tied to this. It's just a way to kind of just think about what you've hopefully learned and kind of try to apply it immediately. So let's look at the first scenario. So you want to migrate to the cloud, but you leverage a third-party application which requires access to the operating system. Which Azure SQL deployment option will be the easiest to move to? So you have some options. So think about what will be the easiest to move to. Now, the second question is, consider the following scenario. You want to migrate to the cloud and remove some of the management associated with SQL Server, but you leverage things like CLR and Service Broker from SQL Server. Which Azure SQL deployment option will be the easiest to move to while also, accomplishing what their goals are? So I see some folks have started to answer, and it seems like we're all pretty consistent. I've seen only A's for the first one and only B's for the second one. So that's awesome. You guys are doing great. Thank you for participating. Let's talk about them briefly. So in the first one, they say they need access to the OS. So this is kind of a dead giveaway. If we do some process of elimination, you don't get that in Elastic Pools, you don't get that in Single Database, and you don't get that in Azure SQL Managed Instance. But you do get it in SQL Server and a virtual machine because you manage the virtual machine. All right, the second one, I think you all got this one as well. It was kind of tricky because they want to remove the management associated with SQL Server, but they leverage instance scope features. So you can't get CLR and Service Broker in Azure SQL Database. You can get them in SQL Server and Azure Virtual Machine, of course, but you can also get them in Azure SQL Managed Instance. And so since they want to remove some of the management associated with SQL Server, moving to a managed service like Managed Instance is going to be better for them. And Francis mentioned, did I miss it or did you define Elastic Pools? I just briefly defined them. I will love to explain them further. So Elastic Pools is basically within Azure SQL Database. And this is really great for multi-tenanted applications. So what Elastic Pools allows you to do is have lots of databases, but those databases can share resources, and so thus they can cost optimize. So if you're, for example, a software as a service provider, I mentioned Paychex as an example, you can manage a bunch of customers' databases and kind of cost optimize based on what they actually use, as opposed to just paying a straight provisioning rate across. So it can be a more cost-effective deployment choice if you have a lot of databases for whatever the purpose might be. Hopefully that helps, Francis. Are there other questions, Alexander, that you think we should talk about?
Not at this time, no. Okay,
awesome, cool. Now, the other thing I want to do is take a minute to kind of show you how we're trying to make this experience a little bit better for you. So let me go to here. And what I'm going to do is go to the Azure portal. And basically what you can do is you can search for Azure SQL. And now sometimes you might see this in your home, but for me, if you don't, you can just search for Azure SQL and select it under services. Now, if I go there, what I'm going to see is I'm going to see all my Azure SQL services grouped together. So what you can see, for example, is, let me make this a little bit easier to see, is if you look at these two columns, I can see all my Azure SQL databases, the type of database I deployed. I can see my managed instance, my SQL servers, my SQL virtual machines, and including that licensing information I was talking about. So we're really working to try to give you this one unified experience, unified view. And to me, it gets better when you go and try to create a new one. So now you're seeing this what to use when, very similar to what I just showed you in slides, but now you're actually seeing it in the portal, and you can click into it and see more information about things like single databases or Elastic Pools, which fall under Azure SQL Database. Now, one of the biggest benefits to me of this new experience, a relatively new experience, is this, because now I have all my virtual machine images in one place, including things like SUSE Celeste, if I want to use Ubuntu, the different versions, if I want to use the developer, enterprise, or standard, and if I have like a bring your own license type of scenario. And if I go all the way down, I can even find SQL Server 2008 R2 SP3 running on Windows Server 2008 R2. So, we even have options for that available. So that's just a brief view at this unified experience. And so hopefully that shows you something that you can go actually do today, and hopefully that'll help when you go deploy, as well as when you think about trying to manage all these resources, keep track of all these resources, being able to see them in one place can help. All right, so we've talked about the deployment options, and now I want to talk at a deeper level of the other choices that you have to make, because there are a lot of choices you have to make when you deploy this. And sometimes it can be confusing, but I really want to show how it's meant less to be confusing and more meant to be a pro, because you have all these flexibility in your options and you can really pick exactly what's best for you. So we're going to talk about purchasing models, and then we're going to talk about service tiers. So the first thing is purchasing models, and this only applies to Azure SQL Database because it's been around for so long. The initial model we went with was the DTU model. And basically what you need to know about this model is that it was meant to be an easy way to bundle compute and storage. So, you just scale up your DTUs and you got, a nice blend of compute and storage. Now, customers like this because it's simple. You just scale up if you need more, scale down if you need less. But customers didn't like this because it didn't allow you to kind of independently scale your compute and storage. Maybe you need a lot of compute, but not a lot of storage, but you're going to have to pay for all that storage in the DTU model. So sometime later, we came out with the vCore model. And this model today is the only option for SQL Managed Instance, but with SQL Database, you still get this choice. And what this allows you to do is actually scale independently, like I mentioned. And because of this model, there are a few more pricing considerations you should take into account. If you're migrating, for example, you can leverage Azure Hybrid Benefit only in the vCore model. So that just means like if you have an existing license, you can use Azure Hybrid Benefit to get something like 50% off of your cost for SQL Database and SQL Managed Instance. So that's a big reason to potentially use this vCore model. And the other thing is it enables you to do something called reserved capacity, which basically means, I'm going to commit to buying a certain amount of resources over the next year or 3 years or something like that. And in return for committing, I'm going to get a significant discount. So from a costing perspective, the vCore model is going to give you more opportunities for savings. So that's something to consider. And there's a lot more we could talk about between here, but what I want to focus on is the vCore model because it is kind of the modern option and it's our recommendation for some of the reasons I just mentioned. So if we talk about service tiers, so the next level, let's say you select the vCore model for SQL Database or for Managed Instance, you don't have a choice, you're just default in the vCore model. The next thing you have to choose is the service tier. And this is an important choice, but oftentimes I think this is a relatively easy choice. So the first service tier is general purpose. So as the name suggests, this is meant for most business workloads. And this is where most of our customers are living today and doing just fine. This is probably the cheapest of the deployment, the service tiers available. And the reason for that, and we'll see kind of this Yelp approach to comparing, is that it's kind of like a failover cluster instance. So we just have a primary for you. And so if we need to do something like fail you over, or you want to fail yourself over, there's a little bit more time involved because we look for a Nova spare capacity. We don't have like a secondary standing by. And then we have the serverless option, which is only available in the general purpose tier. And we'll talk a little bit more about that use case. And I even have a demo for that one. But if we kind of compare it with business critical, which is the next service tier, which is really meant, as the name suggests, for your business critical or mission critical workloads. Maybe you have a gaming application and you really need that low latency, fast recovery, because without that, you're going to have a really bad experience for your users. Maybe you're also doing some read workloads. Maybe you're doing some reporting on top of this and you want a readable secondary. Or potentially you're using in-memory OLTP. Maybe some of you are familiar with that to do faster operations. And what business critical does is we basically deploy an always on availability group underneath the covers. So this is what I was talking kind of at the beginning, where we just do this for you. So if we compare general purpose and business critical, you can kind of see that IOPS, that's IO per second. You're going to get much better IO throughput with business critical. But the con to that is that business critical does cost significantly more than a general purpose database. And you can see that because, not only are we giving you a primary, we're also giving you an availability group with one of those secondaries that you can read from. And that's what the light blue R is supposed to signify. Now, finally, in Azure SQL Database only today, with Managed Instance, something we're working on, we have this Hyperscale tier, which is really fascinating. We could have a whole session on this Hyperscale tier because what we did is we re-architected SQL Server to be built for the cloud. And we'll also take a look at that in a moment. But what I want to show you now is kind of the difference between these failover times when we talk about Azure SQL When we talk about things like general purpose and business critical, we want to look at failover times. If for whatever reason the service or you need to fail over, how long does it take? How much downtime is there? And hopefully what I'm hoping you get away from this is that with both of these options, it's very fast. So let's take a look. So here I have a virtual machine and I'm running Azure Data Studio. If you haven't seen Azure Data Studio before, it's a really awesome tool. I love it. It's fork off of VS Code. So if you like VS Code, it should be very easy to work with. And it also has notebook capabilities, which are awesome. So you can see all these different languages. I'm a big fan of the PowerShell notebook. So that just means these code cells are PowerShell. I can save my results and I can mix in text cells. And my final pitch for Azure Data Studio includes, with normal notebooks, you have to do write Markdown. And here you have that option, but you also have the option to just not write Markdown and just use regular editing, which is nice. So let's get back to the demo, get back to the session. What we're going to do is we're going to look at failover times for a business critical database versus a general purpose database. And what I have here is I'm going to kick off 2 workloads. And what I want you to remember is the right side of your screen represents the business critical database and the left side of your screen represents the general purpose database. Now, a few asterisks. Both of these databases are separate databases. They're not the same database, but they do both have the AdventureWorks database deployed. So they have the same data in them. So what I'm doing is I'm basically using OStress, which is an awesome tool to create workloads on things like SQL Server or Azure SQL. And I'm connecting to it and just running a very simple select statement. And this is on the business critical database. So when I run it, you basically just see 847, which is showing us, the signal to us is that the database is available, right? It's online, it's available, I can query it. Now on the other side, I'm doing the exact same query on an AdventureWorks database, but this time it's running general purpose. So same thing. So basically we're now allowed to see the availability of the general purpose database and the business critical database. So what we're going to do is we're going to force a failover on business critical and general purpose at the same time and see what happens. And hopefully, the demo goes in my favor. So I kick that off. And what we're able to see is the business critical database very quickly became unavailable. The general purpose database followed. And what you usually would expect to see is that the business critical database would fail over significantly faster than the general purpose database because business critical has an availability group underneath. So really all we have to do is redirect your connection to that secondary, one of the 3 secondaries you have hot and running. And then in the back end, we can spin up the other thing, another secondary. Where with general purpose, which you saw also failed over in less than 30 seconds, we have to look for a node with spare capacity and then fail it over, similar to a failover cluster instance. But just from my experience testing this, and it always depends, especially when you do a demo live, is the business critical usually takes between 2 and 8 seconds to fail over, where the general purpose database usually takes about 30 seconds to fail over. So either way, this is really fast. And I want to stress that I didn't have to do anything to set this up, right? I just deployed a general purpose database and I just deployed a business critical database and I kind of got this level of availability right off the bat. And so what I like to call this is the power of PaaS, the power of platform as a service, how it takes a lot of that stuff you maybe didn't really like doing anyway, setting up availability groups, and just does it for you. So with that, I want to take a pause and see if we have any other questions.
No, yeah, I think you're good.
Okay, awesome. All right, so let's continue on. So we talked about general purpose, we talked about business critical. I mentioned briefly Hyperscale, and I just want to talk a few more seconds about Hyperscale. So this is, the great option. If you have more than 8 terabytes, we can now take you in Hyperscale. And Hyperscale, by in theory has unlimited storage. Technically today we support up to 100 terabytes, but there's no reason that we couldn't go higher than that architecturally. So this is really interesting because we've implemented a series of caching layers, which allows us to kind of have a full covering caching layer, which allows us to then do things like snapshot backups, which can be really fast. We also pulled out the log service completely. So you no longer have to wait until your transactions commit in all these replicas like you might otherwise. It just has to harden to the log service, and then you can get a transaction commit. So that's a huge thing. And another big benefit is that we kind of cut down the size of data operation. So you can scale up or scale down in constant time, regardless of if you have a 10 terabyte database or a 90 terabyte database, you can scale in a matter of minutes. Same with a point in time restore. You can do that in constant time. And additionally, we can give you between 0 and 4 readable replicas. So this is really great for read scale. And it's really up to you if you want 0, 1, 2, 3, 4. You can even kind of scale as needed. You know, maybe you're doing heavy reports, so you scale up some of your readable replicas. And when you think about failover, because I did want to touch on that since we saw that, your failover time is going to depend on the existence of these replicas. So for example, if you decide to go no replicas, then it'll behave similar to a general purpose database because we don't have like a hot compute standing by. Whereas if you have one or more replicas, it will behave more similar to a business critical database because we do have something easy that we can just kind of redirect the pointers, replay the log, and then you're back up and running. And so with that, I want to take a look at another example of how you can get read scale with Azure SQL Database Hyperscale. So what I'm going to do, so what we have here is, whoops, give me 1 second. Okay, so I'm having minor technical difficulties. I actually do have this one recorded because there are some things that can go wrong, but not to worry. We will just use the recording. Give me 1 second. Thank you for your patience. Let me turn off the sound.
While you're toying with that, there is a question. Is there a good way to estimate the cost of running a database on Azure Managed Instance?
Sure, that's a great question. A question that is not infrequent. We do frequently get this question asked. So how do I estimate the cost of running my Azure SQL Managed Instance, and how does it compare to, for example, on-prem? A few tips I would say is one, the TCO calculator is something you can use your favorite search engine and search for. Just search for like Azure TCO calculator, and you can manage instance is one of the options. So you can kind of say, okay, based on my usage, this is kind of an estimate of how much it will cost. And the other thing I'll say is, depending on if you're migrating, for example, we also have something called the SKU recommender. So if you, again, use your favorite search engine and search for SKU recommender Azure SQL, what we do is, this is basically through the data migration assistant. There's a PowerShell counterpart which can actually scan your workload and recommend a SKU and also give you kind of a pricing estimate. Again, none of these are going to be perfect, but it does give you some sort of estimate, and you can even apply Azure Hybrid Benefit and see what that discount might be if you have an existing license. You know, this is a question I hear often, and so it is something I'm thinking about. Okay, how can we tell this story better? But today, the best answer I have is to look at the pricing calculators that we have for Azure services, and also check out that SKU recommender. Awesome. Okay, so I apologize that my environment isn't quite great, but I think you'll find this recording is just as good as the real thing, just a little less exhilarating for me because I know it's going to work. So what we have here is we have a write workload that I'm introducing on an Azure SQL Database Hyperscale. And you can see the number of events per second that I'm able to do. And then what I also have on the right side is I'm hitting that same endpoint, so the read-write endpoint, with a read-only type of workload, so some sort of reporting workload. So I'm putting that on, and what you're going to see is while I run this read-only workload on the read-write endpoint, my read-write endpoint is gonna suffer, right? So we see a decrease in the number of events per second I'm able to do while this workload runs. So with Azure SQL Database Hyperscale, I can actually scale up. So you can see I scaled up to 4 readable replicas here. And then I can go back, and I'm using this tool called SQL Query Stress. It's really great for creating workloads on your database. So what I've done is I've spun up 4 query stresses, and I'm using the application intent read only on each of these databases. So that's really going to help me because I can now use these readable replicas instead of using the regular write intent. So for my read-only workloads, I can now do 4 times the amount of work I was doing before, because this is essentially the same read workload. I can do 4 times that and not see an impact on my main writable endpoint where I'm doing, inserts and creating events. So that's, one of the powers of Hyperscale is you can kind of get this read scale out. Not only can you scale up, but you can kind of get this read scale out with your databases. So that's an example of Hyperscale. Again, I apologize, I don't have that demo working today. But that's Hyperscale. That's one of the big benefits, is that you can get this read scale out and you also get constant time operations. I see some of the questions from Jim. Let's see. Vendors claim that the DB can't be in managed instance or Azure SQL database without evidence. I'm not sure exactly what you mean by evidence, but if your vendor does need access to the OS for whatever it is that they're running on their platform, then it's going to be harder for them to move towards Azure SQL Database or Azure SQL Managed Instance. We are finding that many customers, many of our vendors that have these third-party software, which I'm thinking that's what you're talking about, are moving towards starting to certify on Azure SQL Database or Azure SQL Managed Instance, but oftentimes they aren't going back in solutions they've already released that are supported and replacing SQL Server with the managed service. But I would say if they say, depending on what evidence it is that they're looking for, from a cost perspective, we have price performance studies that have been done by a third party called GigaOM. So you can look for those price performance studies. From an availability perspective, you can look at our SLA and see how it compares, see if they have an SLA or see what their backup strategy is. And then you can compare it to ours, and kind of, I think that might help. Happy to follow up offline and learn more about your specific scenario and how we can help convince them. And then your other question, Jim, is, are database backups automatic on managed instance or only OS backups? So database backups are automatic on managed instance and Azure SQL Database. They're taken, I would have to look up the specifics, but we do diff backups very frequently. And we take care of all of that process for you. And we can support you for point-in-time restore between 1 and 35 days. And if that's not long enough, you can also do long-term retention, and you can get retention on your database backups for up to 10 years. So if you had a database 5 years ago that you deleted, but now you're being audited, you need to access it, you can actually restore a deleted database. So very interesting topics on there. I can also share a resource on more about our backup process because it's very interesting. We also give you the option to have redundancy globally, so within your region and a paired region locally, so within the data center that your database backups is stored, or even zone redundantly, so across a region in multiple data centers. So we have lots of options to take care of backups, but yes, backups are completely managed by Microsoft for managed instance as well as single database. Awesome. Okay, so we talked about Hyperscale. The other interesting service tier I wanted to talk about, which is newer, and getting a lot of attention, is Azure SQL Database Serverless. Now, let's take an example scenario. Let's say I work at a company and we have an expense reporting application. Now, this expense reporting application gets intermittent usage. And what I mean by that is people don't use this after business hours. And, a lot of days, some people don't even use this at all, right? But near the end of the month, we see a lot of people hitting this application, trying to get their expense reports in. And so, it really stresses this application at the end of the month. So we need a solution for how to deal with this unpredictable workload with also intermittent connectivity. And serverless is really great for that, because what you can do is you can set a min and a max number of vCores. And what that allows you to do is basically at the min, when your database is online, you're going to be billed for the min. So in this case, I'd be billed at 1 vCore. And then let's say it's the end of the month and people need more, or using the application more, it needs more CPU. It can actually scale on a per second basis to the exact CPU that you need. And then we're able to bring you back down. And then you can set up auto pause delay time. So I think here it's like 2 hours. So this means, at night, 2 hours after no one's hit the database, we'll actually pause the database. And in that case, what we do is we shut down SQL Server, we separate the compute from the storage completely, and you're only going to pay for storage. So if the workload matches something similar to this, either intermittent, unpredictable, or both, then serverless can be a great solution and a great way to save a lot of cost, because the alternative is paying for, 2 vCores the entire time, which, as you can see from this type of workload, is just going to be, you're going to be over provisioned most of the time, and then you're going to be under provisioned near the end of the month. So it doesn't really work. All right, so I have another example for this. And this one, actually, I did have to time lapse. So I also have this one recorded. Again, sorry that I had to record the other one. Usually it's only one recorded demo you have to see. But let's take a look. Let me make that big. Yeah, okay. Okay, so let's take a look. So what I have here is a serverless database that scales between 1 and 8 vCores. You can see by the total CPU usage seconds that it's 0, that currently I'm not being billed at all for that database. Now I'm using OStress to simulate an unpredictable workload, and I can go back to that same query, and what you'll see is I'm going to start to be billed on a per second data basis for what I'm actually using. So this total CPU usage seconds is giving me a good idea of what I actually need for that workload. So you can see it estimates I only need 7 of those 8 cores. So I'm only going to be billed for 7 of them at the time. And I can see the exact number of seconds, as opposed to just being billed at a flat rate per hour on what's provisioned. I'm billed on per second for what I actually use. And we've also implemented a really interesting cache reclamation system, which basically brings you back down from this high memory back down to your min, so that we can then eventually pause you if you want. Now for this database, similar to our example, I set an auto pause delay of 1 hour. So you can see from my compute utilization and the app CPU build, I'm only being billed for the CPU I actually use, and the storage costs are going to be very low on top of it. So you can see some days I'm not even billed for CPU at all because I didn't use the application. Even if I look at a 24-hour, the last 24 hours, what's interesting to see here is not only the compute utilization, but how we actually bring that CPU down. So we're actually able to scale up to your workload, and then we're actually able to bring you back down, which isn't typical to do this sort of memory cache reclamation in SQL. So that's an example of serverless. And let's see. Here, and we'll go here. So I have another knowledge check for you all. I think you all did great on the first one, so I'm hopeful that we'll have some good success here as well. All right, so consider the following scenario. You're moving an application and database to Azure, but your database is currently 62 terabytes with plans to continue to grow. You don't currently leverage any instance scope features. Which Azure SQL deployment option will be the easiest to move to? All right, that's the first scenario. The second scenario is you have an Azure SQL database with the serverless compute tier database deployed with an auto pause delay of 2 hours. After 2 hours of no activity, what happens to your database and incurred charges? So go ahead, and if you know the answer to both questions, just put the answer to both questions in the chat, and then we'll talk about them. So I'll give you guys a few seconds to put in your answers. We have one answer, two answers, keep them coming. We are differing some in our answer to the first question. Let's see if we'll get a few more answers and then we'll continue. Okay, so I have a few answers for the first one, so I'm going to go ahead and start talking about that. So let's use process of elimination. So you're moving, your database is 62 terabytes in size. Well, we automatically know that Azure SQL Managed Instance, we don't have an option to support something that big. So it's not B, which it looks like most of you got. It's not B. Let's also look at what it is. So it's one database. It says your database. So Elastic Pools isn't going to help us either because the max here, I think it's 8 terabytes. I would have to double check, but it's either 8 or 4 terabytes. So Elastic Pools doesn't work for us either. Hyperscale is only available in the single database option today. So D is out of the picture. Now with C, like I just mentioned, Hyperscale could work. And also A, SQL Server and Azure Virtual Machine, this could work. One caveat here, which is tricky, A and C are technically both correct, right? But they do say you don't currently leverage any instance scope features. So this means that they don't need the SQL Server instance scope capabilities that you would get in SQL Server and Azure Virtual Machine. So in the long term, it might be easier for them to move to Azure SQL Database Hyperscale because they don't need those instance scope features, so they can take advantage of this re-architected SQL Server. They can take advantage of the read scale out like you saw in the demo, and they can take advantage of other things related to scaling up and scaling down. So C is like my answer, but A would also be correct. Okay, for the second one, it seems like you all said A. So you're correct. You were paying attention. I appreciate that. Azure will pause your database to stop compute costs and only charge you for the storage with Azure SQL Database Serverless during that pause time. Now, one thing I did want to mention is when you have this pause database, and we get questions about this, is, okay, so my database is paused, SQL Server shut down. What happens when I try to reconnect to this database, say in the morning? Well, your first connection will likely fail. And then what happens when we see the attempt to a connection? We're going to, spin up SQL Server again and reattach your compute and your storage. But this means you are going to start with a cold cache. So this is something you need to be aware of and make sure that your workload and scenario can be okay with this sort of thing. And if the answer is yes, then serverless is still a great option for you. One other option that you have is actually to use serverless, but not enable the auto pause delay. So you don't have to do that if you don't want this thing to ever shut down. And if you have an unpredictable workload, it can still be cost beneficial to move towards that sort of workload. I'm just checking the questions. Don't see any, so we will continue. If you do have any questions, feel free to put them in the chat. Oh, I forgot to highlight the answers. All right, now will we get to a summary? So Azure SQL, so let me start the pitch over. So Satya Nadella, who is the CEO of Microsoft, he says that Azure is the world's computer. Okay, so on the Azure SQL team, we like to say, okay, Azure's the world's computer. Well, Azure SQL has evolved into the world's database. So bold statement, but I think we can back it up. We talked about things like virtual machine, managed instance, and single database, and what to use when. We looked at challenges and solutions. We also looked at some customers. We saw some demos that didn't work, but we had them recorded, thankfully. We talked about SQL Server and Azure Virtual Machine, how it's really great for just 100% lift and shift because it's just SQL Server. It's really just SQL Server. And then we give you some extra benefits from using things like the SQL IaaS extension or just being on our platform. Then we have Azure SQL Managed Instance, the best of SQL Server with the best of Platform as a Service. And finally, we talked about Azure SQL Database, which is the only tier today that supports things like elastic pools, Hyperscale, and serverless capabilities, as well as just, for people who just want to build modern applications. I'm getting my 5-minute warning, which is great. And unfortunately, my dog has not made an appearance. I'm not sure where he is. But that being said, I have tons of resources. I really like to get out in the community and share stuff with folks. So if you want to follow me on Twitter or just follow Azure SQL, our team, you can stay up to date on what's going on. Probably the most important link on this is if you want the deck to this, the deck is at aka.ms/analytics. I think I'm very clever for that. But not so bold as to put it in my Twitter handle. Anyways, it's neither here nor there. So that's where you'll find my deck, all decks from most of the presentations I do. So feel free to steal any slides or resources from that. For the resources, what we have is our GitHub page, which has things related to SQL Server, Big Data Cluster, and other things. Someone just commented they realized there's somewhere else for questions. Yes, there is, but that's okay. We're looking at both. So that's our GitHub page. Highly recommend you check that out. I've got some really in-depth labs in the Azure SQL workshop if you want to dive deeper. One of the awesome things that we recently pushed is a whole learning path related to Azure SQL fundamentals on Microsoft Learn. And if you haven't used Microsoft Learn, the wonderful thing about it is you get a free sandbox environment. So you don't have to have any money to spend on Azure. You just have to have a subscription. And what that's going to allow you to do is spin up 20 sandboxes a day. And each sandbox is 4 hours long. So I think that's plenty. That's like, 80 hours of sandbox per day. I'm not even sure how you could do that. But this is going to allow you to go step by step through some hands-on activities for free as many times as you want related to Azure SQL. So definitely check that one out. Our docs pages are awesome. Whenever I get confused or can't remember something, I just do a Bing or a Google search that says Azure SQL docs availability groups, and then I can go learn more about that specific topic. A few shameless plugs. Bob Ward and myself recently did a 61 video series on YouTube called Azure SQL for Beginners. We go through this content, but then we go even deeper into things like security, performance, availability, hyperscale, lots more there. So check that out if you like to watch videos like this one. And then there's also Data Exposed. Data Exposed is a show I host on YouTube and Channel 9 where twice a week on Tuesdays and Thursdays, we bring in program managers from the Azure Data team. So SQL Server, Big Data Clusters, Azure Arc, Azure SQL. We bring in folks to the show and I ask them about what they're doing. I ask them to show us demos. We talk about confusing topics and I learn hopefully as much as you guys learn. And so definitely check out Data Exposed. And I think that's all the things I had to pitch today. I hope this was useful. Again, I just really thank you all for spending time with me. I know this world is super weird and I wish that we could all be together in person. And I'm really looking forward to a day where I can actually meet some of you on this call. So if you do have questions, I think we have a few minutes. The other thing I'll do is I'll place my email. Reach out to me if you have questions or you want to dive deeper into certain things.
I think your microphone just switched.
Can you still hear me?
I can, but you're way farther away. So it sounds like your laptop microphone or something like that.
Yeah. Let me see if
it was very well behaved to just break down now when you're done. But...
yeah, right at the end. Yeah, it's not picking up my mic anymore. Well, is it okay?
Well, yeah, it is. So now the questions are starting to roll in, or we have one question at least.
Oh,
the name
yeah.
of the
Okay.
tool to estimate the right SKU.
Yes. So I'm going to put that in here. If you just search for data migration assistant SKU recommender. So I think I answered that. You should be able to see that one. But yeah, that's an awesome tool, and we're continuously investing in that. I actually just did a video, I think, published last week about how you can get more out of that tool on Data Exposed.
I might actually sneak in a question of my own here because I've been doing SQL Server since 1997-ish. And one of the main issues that I find with running Azure SQL Server compared to on a VM or on-prem is the I/O. Since I/O is tied to the number of CPUs, that kind of starts to hurt you in a scenario where you need more I/O than you need CPU. Now, that is a good reason to optimize stuff. And I'm sure that Bob would just beat me over the head and say, optimize your darn I/O. But yeah.
Yeah, I
What's
mean,
on
and
that?
I think it's a great question. And yeah, a big one is going to be, okay, try to kind of manage that in ways that you can with regards to like things like if you don't have to create a chatty application, don't do that. Follow the batching best practices. That's going to help. There are a few other tips related to like loading data specifically that can help with IO, but yeah, you're right that some of the service tiers do throttle your IO based on the amount that you deploy. One exception to that is Hyperscale. So we give you, I think, 105 megabytes per second by default. Doesn't matter, how many cores you have. So that could be an option. And also for managed instance, we recently went through what we called the Perf V2 deployment that hit last month. And that basically, I want to say, doubled the amount that you actually have. I think I have it here. So we were able to actually, the slide didn't work very well, but basically what you can see is we were able to increase those based on your workload. But yeah, it does, depend on the amount of cores that you deploy, but it is, like well heard. And I think the best thing I can say is with Hyperscale, you're not going to get those limits as much. But the other thing I could say is like, yeah, there's still, what this proves is like, there's still a big business need for not only organizations, but business people who are consultants who do this sort of thing for a living. There's still a big need for perf tuning and optimizing, that sort of thing. So not the best answer.
Top tip right there, the DBA is not dead yet.
Yes, exactly. Oh, I was just reading the chat. Microphone as a service. Yes, I needed to fail over to a different mic, but
at least you had more than one mic, and that's more than you can say for a lot of people.
That's true. I don't have one quite as nice as yours. I think I need one of those.
Well, what do you use when you're recording the channel?
Oh, I just have a little lapel mic. That's all I use.
Oh, there it is. Oh,
yep.
Nice. Is that going straight into USB or XLR connection?
Yep, it's USB-C. Yep, goes straight in.
Nice. And another completely unrelated question. I see a fighter behind you. What kind of fighter jet is that?
Oh gosh, my husband would be so upset with me. I think it's an F-22. It could be an F-16. He works on airplanes, so.
Right. Well, I'm a private pilot as well, so that's why I saw that thing.
Oh yeah, I think it's I'm pretty sure it's an F-22. Oh, it looks like we have another question.
Yep.
You mentioned some platforms do restrict I/O. How do we look into that? That's a great question. I would say the best way is probably to look at the resource limits, because it's going to depend on managed, like you said, managed instance, single database, and then it's going to depend on the service tier. So I can send a link to one, but if you just do a search for resource limits, like Azure SQL managed, then you can find a list of some of those resource limits. So an example would be here.